Hi, I'm Grace Chapman, and this is my Lab 2 lab report for Physics 2. In this lab, I created two charged pieces of tape and observed the interactions of those tape with neutral objects, negative objects, and each other. I found that the tape was positively charged because the tape was attracted to neutral objects such as my hand, a book, a pillow, and it was attracted to a negatively charged pin that I created a negative charge on. I also found that the tapes were repelled from each other because they were prepared the same way and therefore had the same charge. I used the repulsion of these tapes to actually float one tape above the other. From this relationship, I created two models. In Model 1, the magnitude of charge on one piece of tape is 1.44 times 10 to the negative 9th coulombs. In Model 2, the magnitude of electrical force on one piece of tape is 1.7 times 10 to the 16th newtons, according to my model. The magnitude of gravitational force is 1.96 times 10 to the negative 3rd newtons. The physics principles involved in this experiment are principles of electrical fields, electrical and gravitational forces, and excess charge. An example of this in the experiment is when the one piece of tape floats above the other. In this situation, the electrical and gravitational forces are acting in equal but opposite directions, but they have an equal magnitude. That causes one piece of tape to float above the other. Applications of this experiment are modeled in code that I wrote that models forces acting on the system. The length of one of my pieces of tape was 20 centimeters. The mass of one of my pieces of tape was 0.2 grams. The distance between the two tapes when one began to float over the other is 1 centimeter. The magnitude of gravitational force on the floating piece of tape is negative 1.96 times 10 to the negative 3 newtons. The magnitude of electric force on the floating tape is the equal magnitude to the gravitational force in the opposite direction. That makes this value 1.96 times 10 to the negative 3rd newtons. The coding aspect of this lab called to create a model that modeled the different forces acting on this system. The white arrow shows the electric force, the yellow arrow shows the gravitational force, and the small green arrows are modeling the individual electrical forces on each of the point charges. The magnitude of electric force according to this model is 1.7 times 10 to the 16th, and the magnitude of gravitational force is 1.96 times 10 to the negative 3. However, the magnitude of this electric force seems off to me. It seems far too high for the nature of this experiment. However, I was unable to find the bug in my code. I checked it against the source code several times, and I'm unable to find it. So for the remainder of this lab report, I will just act as if it came out to be a more normal number. For the assumptions, I had to assume that I could ignore air resistance on a moving object. Although the top tape isn't moving, it does have to move to get to the floating position, so I'm still ignoring air resistance. I assume assuming that each U-tape I made had the same amount of charge evenly distributed along the length of the tape. In this experiment, I did not have to assume that I could treat each piece of tape as a point charge as I did in Lab 1. Conclusions. I was able to conclude that the U-tape is positively charged. The force due to gravity is negative 1.96 times 10 to the negative 3rd newtons. The electric force is 1.96 times 10 to the negative 3rd newtons. The magnitude of charge on one piece of tape is 1.44 times 10 to the negative 9th coulombs. The magnitude of electrical force, according to my computational coding model, was 1.7 times 10 to the 16th newtons, which isn't what I expected. And again, the magnitude of gravitational force, according to my coding model, is the same as above, 1.96 times 10 to the negative 3 newtons. Questions about my experiment. What if I modeled each tape as a single point charge? Again, my line charge model was incorrect. But ideally, the charge from this lab would be more accurate than the charge from the last lab. This is because instead of just having 2 point charges, the model considers 22 point charges, 11 on the top and 11 on the bottom. This would make the model more accurate because it is closer to what the actual physical system would look like. In reality, there are not even point charges, just each atom is acting as its own charge. So 22, while it is still far away from reality, is much closer than 2, which would make this model ideally more accurate. Therefore, the value from this model would be very close to the value from the first model.